Hello and welcome back to Solving LeetCode for beginners like myself. Um, so today we're going to be solving linked list cycle LeetCode 141. And I honestly think that if you're starting out LeetCode, um, this one and designing a linked list, obviously, implementing a data structure from scratch will be best for your understanding of the dot value and the reference and how linked lists sort of all work together, right? The one you should try after this is gonna be we're gonna solve it in the next episode. That's just reverse linked list, right? But I think linked list cycle is actually a really good problem for us to understand. Okay, so given the head of a linked list, determine if a linked list has a cycle in it. So basically, we're essentially finding out if a node has a pointer to a previous node in the list. So in this case, 4, -4, um, position 0, 1, 2, 3. This node is pointing back to 2. So therefore, there has been a cycle. And we can do this. There's something called a two-pointer method, right? And this algorithm is called I believe it's called tortoise and a hare. And why is that, right? We're going to have a tortoise, right? We're going to have a slow pointer and we're going to have a fast pointer. And basically, the slow pointer is going to move by one step at a time, and then the faster pointer is going to move double time. And we'll see why this works. Um, let's say we have a linked list like built like this, right? And 4 points back to 2. So yes, this linked list has a cycle. Um, essentially, our slow pointer is going to start here, and our fast pointer is going to be here. Why is this important? Because this fast pointer, the main idea here is that it will always, if there is a cycle in the linked list, we know that it's going to catch up to the slow pointer eventually because it's double the speed, right? So I'll show you in this iteration. So the first, we start here. We shift dot next. Oh, actually, my apologies. The fast pointer would be here. Slow pointer because it would be here dot the head and it'd be dot next. So in the first iteration of the cycle, this slow pointer would walk here, and then our fast pointer would walk 1 to 4, and then back to 2, and then meet. So basically, if the slow and the fast pointer meet, so if slow is equal to fast, we can go ahead and return true. I can show you this on a larger example. So let's extend this. Right. So let's say 6 points back to 3. So slow pointer starts here, fast pointer starts here. So slow pointer moves here, fast pointer moves 1, 2, and then slow pointer moves here to 3, right? And then on this iteration, the fast pointer will be 6, and then since there's a cycle from 6 starting to 3, right? They will meet again, and this is the main idea of our list. So we can go ahead and delete that and get to the coding part. So we can start off by initializing our slow pointer and fast pointer together, right? So what we want to do is while fast and fast.next. So basically what we're saying here is while fast and fast.next still lands on a node and it's not equal to null, we want to keep going. And we want slow to be equal to slow.next, and then we want fast to equal to fast.next.next. Because this one is going times 2 speed, right? And if slow, or it doesn't really matter, if slow is equal to fast, we want to return true. Otherwise, if this condition never executes, meaning that fast never equal to slow, and fast or fast.next reached it got to the end of a linked list, let's say like this, it reached in Python, no is none. So it will break out of that loop, and then we will return false. So let me just run this real quick to see if it works. And there we go. Case 1, 2, 3 accepted. Let's see. And yeah, pretty simple problem. Pretty straightforward. Um, yeah, this is one of those classics. And I think everyone should learn. Let me know if you have questions in the comments. I'll see you in the next one. Peace. Oh shoot.